Hey, so in this lecture I want to introduce arrays of pointers. Now to get started here, we are familiar with this sort of syntax. We create an array of integers called a myArray. Following the name of the array, we have the subscript operator, and we specify the size of the array within that. In other words, how many elements of that type, in this case int, the array will have. In this example, we will have 3 elements. We can initialize the array using list initialization, so I pass in 3, 5, and 9 to initialize the integers within the array. And as you can see in the illustration, we have the array of integers. To the left I have myArray subscript operator and then a 0 for the first element, and so forth, and to the right we have some example addresses. The array is a contiguous block of memory, but you can think of it as 3 integer variables next to each other in memory. Next, let's look at a quick high-level example of an array of pointers. We can read the array from right to left as we can do with pointers. We have the subscript operator, meaning that this is an array. In this declaration within the subscript operator we specify 3, so this array will have 3 elements. We give it a name, in this example pointer array. Next, what will the array store, or in other words, what type will the elements in the array be? Well, in this example they will be pointers to integers. Of course, those can be pointers to other fundamental types. They can also be pointers to user-defined types such as a class or a struct. But in this example the elements within the array are pointers to integers. The elements are basically variables, and in this case those variables are pointers. In the illustration you can see we have an array of pointers, point array with the subscript 0. In other words, the first element of the array of pointers stores an address, and at that address it can store some value such as 3 in this example, and so on. And the third element in the array of pointers, with the subscript 2 of course, may store some address to an integer that stores 9 in memory, for example. Now we can get the address of, let's say, the first element in that array using the array name, in this case point array, the subscript 0. We prefix that with the address of operator. That will basically return the first address in the array, or in other words the address of the first pointer variable within that array. Then, as with any other array, we can get the value that is stored at a particular index, so in this case 0 again, that is the first element in the array. This will return an address as opposed to an integer value or float value and so on, because this is an array of pointers, and of course a pointer stores an address. But now we can use the indirection operators. We can prefix the array name with the indirection operator and basically dereference the address that it returns. And in that way we can fetch the value that is stored at the location where the pointer is pointing at. In this example, where the first pointer in the array is pointing at, we can fetch that value, so we are going to fetch 3, or we can write to that value. Okay, let's go and look at a few examples in Visual Studio. In this quick example, in the main function I have a constant array size because I'm going to use that for the array. And then I have 3 variables here, x, y, and z. X is initialized to 3, y is initialized to 5, z is initialized to 9. Then I have this pointer array here. Okay, pass in array size here for the size of the array, and then I have the address of operator and x for the first element. Okay, so I'm gonna save the address of x within the first pointer variable within the pointer array. Again, the pointer array is an array of pointers to integers, so the elements within the array are pointers to integers. Okay, they are not regular variables. They are pointers which will store addresses. So the second element will store the address of y, and the third element will store the address of z. Then I have a for loop. Int I is 0, I is less than array size. Okay, then I'm gonna do console output, and I fetch the pointer array I. We'll start with 0 again, 1, and so on, and then I'm going to dereference whatever that returns for us. For example, let's say this is 0, right? So in the first iteration of the for loop, this is going to return the address of x. Then we dereference that, and of course that is going to fetch the value that is stored at the address where the pointer is pointing at. In this case, the pointer is the first element in the array. So we get that 3 value, we print that out, and so on. Let's pull and run that so we can see the output here. It prints out 3, 5, and 9. I'll show a different example here in just a second, but now I can also make indirect changes to the variables. So in this case I am dereferencing again the first element in the pointer array, which again is a pointer. Okay, so I dereference that, I get the address, and then I assign this value. I store this value at the address that this is going to return. Okay. Add a tab at the end, and I'll build around that. And now we get that value 3, 3, 3, and then 5 and 9. To expand on the previous demo just a bit, I have the addresses here, so I'm going to print out the address of x, y, and z in these console output statements. Okay, so the rest of the program is the same. I still have the array size, the 3 variables here, x, y, and z. I have the declaration and initialization of the pointer array right here as before. But now in the for loop, what I'm going to print out is this right here. Okay, in the first console output statement in the for loop, I get the address of the first element, for example in the first iteration, and then in the second and so on. So this is going to be the address of the actual pointer element which is stored in the pointer array. Then we get what that stores, which will be an address, because again this is an array of pointers. Then we dereference that, which should fetch the value that it stores at the address where the pointer is pointing at. Okay, let's build and run that. And we can see the address of x, y, and z. Those are stored in this middle column. Remember, I do this right here in the second printout, where I basically fetch what the value is that the element stores. And since in this case we have an array of pointers, those elements will store addresses, as we can see here, and they match with the address of x, y, and z, and we get those values printed out. Each element, or in other words, each pointer in the array will have its own memory address. It stores an address because it is a pointer, and we can use indirection, so by dereferencing using the indirection operator, we can access the value that is stored at that particular memory address. We are simply printing it out, we are fetching it, but of course, as I showed you in the previous example, we can also write to that variable indirectly. One more example using a user-defined type, the entity class. In the public section, I have the constructor, which is going to print out entity constructor invoked, the member is, and it's going to print out the member. We have an integer member here. It's also going to assign in the initialization list, it's going to assign the member parameter to the member. And in the destructor, it's also going to print out entity destruct invoked, the member was, and then member. We may change the state of an instance throughout program execution. Then I have a void toString function, which is simply going to print out the member. And I also have a setMember function, which is going to assign the parameter, the member parameter, to the member as well. Just a really simple, generalized user-defined class. Okay, in the main function, I have the array size again, which is a constant integer. And then I have two entities. I instantiate entity twice, entity 1, entity 2. For entity 2, I pass in the integer literal 5 for the construction. Now for entity 1, it's going to use the default argument of 0 here for the construction. Okay, then next I have the pointer array, which in this example is now a pointer to entity. Alright, so the pointer array is an array of pointers to entities. I use list initialization and I set the first element to the address of entity 1, and I assign the address of entity 2 to the second element. We can also do this sort of initialization. If you prefer this sort of initialization, that's fine. We have the assignment operator. Maybe that's easier to read for you. Now you can do a for loop, but in this example I'll just work with the elements directly. So for the first element in the pointer array, let's say we want to do the toString member function for that. Okay, we have the toString member function right here. How do we access that? Well, instead of dereferencing whatever this is going to return and then using the dot operator on that, what I'll do instead is I'll use the arrow operator. And you can see we get the list of member functions in the IntelliSense now. And just as a quick example, I'll do toString and I'll build and run the program here. Remember, we instantiated the entity class twice. We have two constructions. With the first instance, the member is going to be 0, and with the second instance, the member is going to be 5. It prints out 0 with the toString member function invocation. When the program exits, those entities are destroyed. They're on the stack, not on the heap. Okay, let's make a change to that first element. I'll invoke the toString function for the object that the second member is pointing at as well, which in this case will be the entity2 object. Okay, so with this statement, we're invoking the toString function on this entity 2 indirectly. Okay, that is the second element in the array, and because that is a pointer, we are indirectly calling the toString function on that. And here with this statement, we access the first element, which is entity 1. We indirectly invoke the setMember function on the entity 1, and we make a change to that, we make an assignment. So let's build around that. The constructors are invoked, we get 250 and 5 printed out, and we get the destructors, and we can see the member is now 250, so we modify the state of that object during program execution. With the list initialization, the third element in this pointer array should now be initialized to null, because list initialization works in that way, right? It's going to initialize whatever we don't specify explicitly, it's going to initialize to null. But if you want to, you can be explicit and initialize that to null pointer, and we'll look at that here shortly. For example, If the third element is null pointer, then I'm going to print out a null pointer. You can build around that to test that, and we actually do get a null pointer. But if you do want to be explicit, then you can add a null pointer in that, and then later on during program execution, you can set that to point to something else. Store the address of something else in that, so we can see we get a null pointer printed out. That is going to wrap up this lecture on arrays of pointers.